Okay, here we are at the injection molding station. A couple of things about injection molding. Injection molding is the most widely used process of forming thermoplastic materials. So a couple of things that would make a product not be able to be injection molded. Maybe it needs to be hollow. This process can't make a hollow product. Maybe we have to think about how it's removed from the mold. Certain project shapes might be an issue. But in general, if it can be injection molded, companies are going to want to injection mold it. And here's why. Injection molding can make a lot of parts in a really short amount of time. The faster we can make parts, the less we can charge for them, the more we can sell. A lot of times with injection molding, they'll use a runner system, so in one injection cycle, we can make a lot of pieces in one cycle. In class here, you're going to make screwdriver handles. These handles have been injection molded onto these screwdriver metal bits. This one is a Phillips driver, this one is a standard driver. You're also going to make a golf tee, and I'll show you the process for making a golf tee here in just a minute. Let's take a look at all the pieces involved in the process for our lab. This is a vertical injection molder. Okay, we are injecting from above. This is a 1.1 ounce injection molder. That means I can have 1.1 ounces of material in the heating chamber and be able to inject 1.1 ounces of material into our molds. This is also a pneumatic-powered injection molder. And pneumatics means air pressure. Right now I have my injection molding machine set to about 95 psi, or pounds per square inch of pneumatic or compressed air. So as I drop this down, you can see the ram is powered by the pneumatic pressure from the air compressor. I'm preheated to 350 degrees. We're going to use a polyethylene. I have two different options. I have a LDPE for low density polyethylene. These beads have been colored with a blue pigment for class. And I also have an HDPE for high density polyethylene. Both are polyethylene, but the thing about polyethylene is it can be made in different flexible or different squishiness. If I'm going to make a screwdriver handle, I want a little bit of squishiness and a little bit of a grip. I'm probably going to use a low density polyethylene. You're probably not going to notice much on a piece this size, but as we get bigger we'll see we have a little bit more grip with low density polyethylene. If I'm going to make a golf tee, that golf tee needs to be pushed into the ground. Okay? If it's cold outside, if the ground's tough, a low density golf tee is going to bend. A high density golf tee is going to be able to push into the ground better. So today we're going to make a golf tee out of high density polyethylene beads. So let's see how this process works. Let's take a look at the molds we're going to use for class. These are injection molding molds. They fit together. We have an opening for the material to be injected into. Here's our screwdriver mold. Okay, so we would see that our screwdrivers would sit right here, our bit. We see where the plastic comes into the mold. We also have these indexing pins and indexing holes. So there's no way to put this together in incorrect fashion. All right? My next job is to slide this underneath the injection molder nozzle so that plastic can enter into that opening. We call that opening the sprue, where the plastic enters the mold cavity. Let me open this up again. In a single cavity mold, such as this screwdriver handle, the sprue goes right to a knockdown opening, a little smaller, that we call the gate. From the gate, the plastic will fill the mold cavity, making the part. Now the reason the gate's a little bit smaller is because we want our workers to be able to remove the plastic product from the sprue. In multiple cavity molds, the sprue would go off to two different runners, and those would go off to sub-runners, and we could make 6, 8, 12, maybe 24 pieces in one injection. So the runner system will split the sprue into different directions, and from each runner would be a gate to each individual mold cavity opening for each part. Our class, we all have single cavity molds, so we won't see any runner systems in the molds that we have. So let's take a look again at our golf tee mold. If I open this up, I have my indexing pins to hold it in the correct fashion to each other. I have my sprue opening where my plastic is going to enter the mold cavity. So my challenge is to get this correctly placed underneath the nozzle of the injection molder. Let's do that now. So my challenge is to get this sprue underneath the nozzle in the correct location. Here's where students struggle the most. It's kind of difficult to see where the sprue is. and the injection nozzle. And I also have the ability to extend or retract that stop. So once I get it in the right spot, it's repeatable. The next thing I want to do is adjust my clamping pressure. This is a mechanical clamp. Right there is the perfect amount of pressure. If I can't get that to detent down, this is too long. I need to loosen up my stop nut and retract that a little bit. Okay. The clamping pressure needs to be stronger than the injection pressure, otherwise our mold would open up, creating all kinds of excess plastic on our part. Now we're going to put some pellets into our hopper. Now this has been plugged in this whole time, so we're up to temperature 350 degrees. When the red light comes on, the machine's telling you it is up to temperature, it is ready to use. Okay? If I take a look at my dial gauge, I can see I'm at 350, maybe even 360 degrees. So this is now ready to fill with my pellets. Now remember, I'm making the golf tee, so I want to use high density polyethylene pellets. Besides the color, let's take a look at each of these pellets. Okay, I'll get these nice and close to the camera here. Besides the color, let's take a look at these pellets. You can see that the low density pellets have a little bit flatter look to them, and they're a little bit bigger. The high density pellets are a little bit more round and a little bit smaller. Some students say, what color pellets do I need to use? These colors change weekly. It's not the color, it's the density. So again, high density for the golf tee, low density for the screwdriver handles. This tool makes it really easy to carefully fill my hopper, trying not to spill my plastic pellets all over the place. That should be plenty to make one golf tee, but just to make sure we have enough for pressure to push down. And notice I'm doing my best here not to spill these pellets all over the hopper. In industry, we would have a horizontal injection molding machine like we mentioned, and instead of a plunger, we would have a screw ram. And as that screw turns, it's going to move the pellets to the injection station, and it's also going to heat them as they move a little more evenly. When we have a plunger style injection molding machine, that heat needs to penetrate through the pellets. So the outside pellets are going to be melted first, but I have to wait for the core of the pellets to be melted. Typically this will take about 2 to 3 minutes. Now we've waited a few minutes. Our beads should be melted by now. I hope that I've got everything lined up underneath the injection nozzle with the sprue opening, and we have this clamp shut. Our air pressure is ready to go. I'm going to drop the hammer here. You're going to notice a quick injection and then real slow. If I continue to hold the handle down, all that real slow downward motion, the only thing it's doing is forcing extra plastic into the mold, resulting in a lot of excess plastic around your part we call flash. I'm going to try to avoid that. So here we go. Hear that crackle sound? That's air escaping out of every part of the mold. Now I can take back my clamp. I'm going to get my mold out of here. And let's see if we have things lined up. See, we have a little bit of excess coming out of the sprue. But if I open this up, you'll see that I have a complete golf tee. It's still warm. Okay, it's not hot, but it's still warm. If I were to pull this out of here, I might curl it. So I want to be careful as I take this out so that I don't deform the product. Let's take a look at our product. Sprue needs to be removed. It's easy because the gate is very small, and I can easily remove the product from the gate. Excess plastic around the product, remember we call that flash. A nice exacto knife will take off any excess flash, and I have my finished golf tee. Let's make a screwdriver handle. Now to make a screwdriver handle, I have the mold. Again, I want to put a bit into my screwdriver handle mold. Now remember, the screwdriver handle is made out of low density polyethylene. I'm going to put this purge block underneath there, and I'm going to purge out all of the high density polyethylene. So now I want to fill this with low density polyethylene beads in the same manner. Try not to spill them all over the heating chamber. So again, we're going to make our screwdriver, and I'm going to make a Phillips screwdriver today. You'll see the screwdriver blade has some embossing on it that's going to help it stay put into the plastic. Biggest mistake I see students do is they push this too far to the back, and that shaft of the screwdriver is exposed in their handle when they're finished. Or they come too far forward and the embossments are exposed. I want to try to get that just below the sprue. Let's line up our indexing pins. And that can be loose in there for now. I'm going to put this in from the side, and again doing my best to line up my sprue with my injection nozzle. I'm going to push my screwdriver bit till I feel it hit the back. I'm going to pull it till I feel it hit the front. I'm going to go about halfway. Then we're going to take a look at our clamping pressure. Should hear it detent down, and it does. So again, I'm going to wait just a couple of minutes until my beads are melted. Hopefully I have everything aligned. Let's see how this works. And back up. Give it just a few seconds to cool off, and here's the moment of truth. Looks pretty good. I got a little bit of plastic at my sprue, and as I open this up, I have my screwdriver handle. Very little flash. Again, we can remove the sprue with a sharp exacto or just a simple twist because the gate was just a very small opening. And there's my finished low-density screwdriver handle for a Phillips screwdriver bit. For class, we're going to have to make a Phillips bit, a standard driver bit, and the golf tee.